Alright, in this video we're going to continue on with applications of quadratic functions, and in this video we're going to talk about maximums and minimums. So on the left it says an object is thrown upward from the top of a 100-foot cliff. Its height in feet above ground after t seconds is given by the function f of t equals negative 16t squared plus 10t plus 100. Find the maximum height of the object and the number of seconds it took for the object to reach its maximum height. Now, we just finished a video talking about when an object reaches a certain height, and the method for that was to plug in the height and then solve the remaining quadratic. This problem is asking to find the maximum specifically. So we don't know the height, but we can identify the maximum because with any quadratic function, the max is the vertex. So whenever you see maximum or minimum as part of the problem, you are actually finding the vertex. And we have a vertex formula that says, in this case, t is the variable, will equal negative b over 2a. So we can find the time that it reaches the maximum, and then once we have time, we can input that and find the maximum height. So looking at our equation here, we know a is negative 16, b is 10, and c is 100. So negative b would be negative 10 over 2 times a, which is negative 16. And negative 10 over 2 times negative 16 is negative 32. And a negative divided by negative is going to end up positive. And we can simplify that fraction 10/32 by dividing out a common factor of 2 and getting 5/16 seconds. Or, depending on how your homework wants you to put that in, it's a decimal of 0.3125 seconds. Either one of these would be acceptable depending on the directions that you're given. Do not round. So it doesn't say anything about rounding. So if you do write it as a decimal, don't round that. Take it out to those 4 digits or as far as it needs to go unless otherwise specified in your directions. Alright, so that's the time. So when we solve using the vertex formula, that's the input. In this case, the input was t. So now we can find the height by plugging in f of t. So f of, I'm going to go ahead and use the decimal form here. And everywhere we see an x, we're going to replace it with 0.3125. So negative 16 times 0.3125 squared plus 10 times 0.3125 plus 100. And first we do the order of operations, so we do the exponent first. So this is going to be a long decimal, 0.09765,625. Again, you're not rounding anything. We will round the final answer if we're asked to. And I multiplied here times 10. Still have plus that 100. We can multiply negative 16 times that big old long decimal, and we get negative 1.5625. And then I'm just going to add left to right, and I get 101.5625, and that was in feet. So that should be the maximum height. So at 0.3125 seconds, we'll reach a maximum height of 101.5625 feet. Alright, so again, it all comes back to that vertex formula. Negative b over 2a gives us the input, which in this case was t, so it gives us the time. Take that, plug it in the function, and that gives us out the height. Go ahead and try the example on the right. Okay, the problem says, the company wants to minimize the cost to make their product. It was determined that when X hundred units of the product are made, the average cost per product can be estimated by C of X equals 0.1 X squared minus 0.9 X plus 2.45, where C of X is in hundreds of dollars. What is the minimum average cost per product, and how many should be made in order to achieve that minimum? So in this case, it's a minimum. So again, it comes back down to the vertex formula, because with a quadratic, the minimum is also the vertex. Okay, so max or min, you need to find the vertex. In this case, X is hundreds of units of the product. So the input here is X, and that's going to give us how many products we need to make to reach that minimum cost. So still using the vertex formula, negative b over 2a, and b is negative 0.9, a is 0.1. So negative 0.9 divided by 2 times 1/10. 2 times 1/10 is just 2/10. And divide. Oops, sorry, this is negative, so that makes that positive. Right? Our b was negative 0.9, and we're taking negative b. So negative makes that positive. And then we're here, we divide 0.9 divided by 2/10, and we get 4.5. Now that doesn't mean we're making 4.5 products, because this is in hundreds. So X is in hundreds of units. So really we would multiply this by 100 and get 450 units. So you would need to make 450 units to get the minimum cost per product. Now what is that cost? Well, we have to plug in our answer. So C of, using our original answer, because X is in hundreds of dollars, or hundreds of units, so we're going to plug in 4.5 and evaluate our function. So plugging in 4.5, everywhere we see an X, that is a 4. And using order of operations to simplify. So 4.5 times 4.5 is 20.25. 0.9 times 4.5 is 4.05. Multiplying 1/10 times 20.25, we get 2.025. And then adding this up from left to right, we get 0.425. Now C of X is also in hundreds of dollars, so it doesn't cost basically 43 cents. We have to take that answer and multiply it by 100, because it's in hundreds of dollars, and we would get $42.50. So the minimum cost to produce that product would be $42.50, and we would have to produce 450 units to reach that minimum cost. And there you go. So again, max, min, you see those in the problem, and it's a quadratic function. The max is always the vertex, the minimum is the vertex. We're going to use that vertex formula, negative b over 2a. And that always gives us the input of the function, so x in this case, time in that case. You plug that back into the function, and that gives you the output, cost per product, or height for these two scenarios. Alright, good luck on your homework.